Hello, everybody. My name is Mike Zephyr, and I'm an associate professor here at the University of Melbourne in the Faculty of Business and Economics. And this is QMNET, or the Quantitative Methods Network, which is an informal network of like-minded quantitative researchers at the University of Melbourne and elsewhere. And today we've got a very interesting and I think kind of funny talk by one of our own, and it's Patrick Laub, who will be talking to us about a software engineer's toolkit for quantitative research. Patrick is a mathematician and software engineer, currently working as a postdoctoral fellow with us here at the University of Melbourne. And he's interested in the intersection of mathematics and statistics and computing, and has previously interned at Google and worked for Data61. His recent research topics include empirical dynamic modeling, approximate Bayesian computation, and Hawkes processes. And you're writing a book on Hawkes processes, aren't you? Yeah. So everybody stay tuned for that. And Patrick's joint PhD in computational applied probability was completed between the University of Queensland and Aarhus University. I'm sure I'm saying that incorrectly. For further information, you can scroll below and go to Pat's GitHub page, which is pat-laub.github.io. And Pat, thank you so much for doing this, and take it away.
Thanks, Michael. So the talk today, I realized when I was preparing that I kind of overpromised all the different things that you could easily fit inside a 50-minute period. So some of these topics, I'll be giving a few demos here as in the outline, 4 main demos, and then some other topics I'll be very briefly skimming over or skipping entirely. So the first one that I'll be looking at is using Python and Jupyter notebooks together, and in particular using them on a remote machine. So my setup is I'm switching between a Mac at work, a Surface, a laptop at home, or even an iPad. But most of the time I'm accessing a cloud virtual machine that we have from the Melbourne Research Cloud. And that's a very powerful machine, 80 virtual CPU cores. So this is the reason I'd like to keep connecting to it, but there's lots of reasons why you would want to connect to a remote machine to work off, like lots of software, for example, only works on Windows. So you could remotely access a Windows machine, or the opposite is true, things that only work on non-Windows. As I said, my reason is I just want the fastest machine possible to work on. I've also had the situation where I needed to use data from some company, but they wouldn't give me permission to copy the data off their servers. So I would remotely access the data in this kind of way, so to get around these sort of privacy constraints. So get straight into it. Jupyter is this program here that I've got installed. So I'm not going to actually run this Jupyter notebook because it'll start up on my computer. But what I want to do is start up this notebook on our Melbourne Research Cloud computer. I forgot to mention. There's lots of software to remotely access another computer, but like the entire display of another computer. But actually, I'm going to be mainly working in the terminal. I don't know if you can see this, but this is some really, it's an advertisement that I found for the Windows terminal that they produced this year. Let me change one setting. It's kind of, I just find it hilarious. So I just wanted to show you. But basically a terminal, I'll open it up. Windows terminal is just a black box that you can run programs in and you get output. To be fair, this Windows terminal, it is quite good. They just updated it recently, so you can get quick access by pressing Command or Windows and the backtick button, and it pops up at the top of your screen. It's called Quake mode. So I'm going to use that to get a secure shell connection to our machine. So the way this works is I get a terminal. It looks like I'm running programs locally, but it's actually sending my commands on an encrypted channel through to the other machine, doing it over there, sending the encrypted results back to me. I've set up that my password and so on. So it's pretty easy. I just type SSH MRC to connect to the remote machine. But I'm going to do that a second time because to run Jupyter, it'll actually open up a website on the other machine, and I need to sort of forward that website back to me. So I have to add in another flag here, -L, and then some numbers. You can make a shortcut for this if you want to avoid that. And to start it up, Jupyter Lab starts Jupyter. Now, if I just go to the website, which is localhost 8888, it will connect through. And it's being quite slow right now, which is ominous, very ominous. Anyway, so this is the interface for Jupyter Lab, the more up-to-date version. If you've heard of Jupyter Notebook, this is the new and improved version. So the idea is that you have this notebook-style interface where you type in code and run it cell by cell. And this is just defaulting to Python because that's what I installed, but you can use any languages here, really. So let's start doing some Python things. Just change to the right directory. So I've got just a text file here I downloaded with a whole bunch of English words in it. And the reason I have that is to show off like the thing that I was most impressed by with Python when I first learned it back in 2009 or something like that. And that's the string processing capabilities. Like just reading in those words and just imagine this very silly example that we're doing some kind of crossword solving puzzle. And I want to find, oh, sorry, this is probably too small to read. I want to go through each of the words in my English database, find each word that starts with HE, has Pat in there somewhere, and has 7 letters in it. Then the code is just super easy to read, and it's almost like English language, the way you would set that problem. If me to explain it to you, the Python is very similar. Now to get onto some math stuff, the Jupyter Notebook is quite powerful because you can put both Python code and I don't know, and Markdown. I'm not sure why that's not working at the moment. But I can show you an example of some Markdown slides. And by Markdown, I just mean it's a language where you can just put any anything. You can just type out any text you like and insert maths inside it. So these are Jupyter Notebooks slides that I made for teaching when I was teaching this class in France. And I could have the maths here explaining the concepts and then have some code that would produce the plots. And with this one, if I can just go down to File, Export as reveal.js slides. And let me show you what that looks like. So that notebook then spits out like a presentation that I can use directly with all the maps inside it and the plots when I get to them eventually. Yeah, and there's another version of this where you can even sort of write code inside your slides and it'll run the code. That's called Rise, but I had trouble with that, to be honest. anyway, back to my original notebook. Let's start doing some number crunching. So when I start any new programming language, the first thing I do is try to make a function that calculates if a number is prime or not, just as a simple test way to get used to the syntax of the language. For that, it basically boils down to a few special cases for small numbers, and then checking every odd number up till the square root of the number that you want to check. So making another function which just simply looks between a start and an end point and tries to count how many primes are in that region. It's very simple, and if we try to run that, say how many primes are in the first 1,000 numbers, we get 168. Jupyter is kind of quite cool, as in it has extra commands built in called magics. So the one that I use all the time is %time. So I can go %time, count primes, and see that took a few microseconds for that command to run. Counting the primes in the first million numbers is a bit more time, 2 seconds. There's a few libraries that I always use for in this kind of situation. The first one is one of my students actually told me about, TQDM. So by inserting just one more letter into this script instead of range, trange, I can get Jupyter to produce this really beautiful progress bar. So I'm often running code that takes hours or days to run. So I really need to know how long it's going to take. Another twist on this is to actually make the code faster. So this is another language, a package that I've fallen in love with recently, Number. And the way it works is if you just add these few characters in front of your function, njit brackets, then when you run it, it crashes. Why does that happen? Ah, sorry. It won't compile that progress bar. Now think about it, I need it for the isPrime function as well. So when you run it and you've done it properly, it goes a lot faster because it has compiled the Python code down to C code actually. And so that million prime check went from 2 seconds to 200 milliseconds. And if I do it again, it'll be even faster. It'll be 71 milliseconds. And that's because the first time you run it, it'll take a little while to do the conversion from Python to C. But after that, you can get sort of a really massive speed up just for really no effort. One other cool thing about it is you can easily parallelize your code. So here, if I'm counting the number of primes, it really doesn't need to be done all at the same one after each other. So I can change the range to a P range, rerun it. Again, the first time it's a bit slow, and now it's faster, so 3 milliseconds. To prove that it's actually doing things in parallel, let's bump it up and count how many primes are in the first trillion digits. And while that's running, we can open up a terminal. Very slow. And if we run the Linux version of like Task Manager, which is htop, we can see that all the 80 cores of the machine are being fully utilized. So dropping off now it's sort of finishing up their jobs. And in my previous tests, it can calculate these primes in about 30 seconds, whereas if you did it without the parallel flag, it takes 20 minutes to do. Okay, so some brief notes. So this is just a diagram showing how I connected and using that flag to create a secure tunnel to send the Jupyter information backwards and forwards. If you want to just run Jupyter notebooks without bothering to install anything, then Google has the Colab that you can use, and it's a Jupyter lab inside your browser. Just go to the Colab website, and it even gives you access to a GPU for free. So if you're doing machine learning tasks, this is actually quite a cool option. I might skip over that for now. I don't want to spend the entire talk talking about different programming languages, but I looked up, well, the different popularities, and Python is ridiculously popular at the moment. So, I mean, in general, there's so many advantages to working with such a popular language. Everything has already been done for you in a lot of ways. But comparing, I looked at a few different mathematically inclined languages and looked at when they were last updated, and there's lots of work being done on all of them. So like Python was updated at the end of last year. C++ in particular, I want to highlight, it's been updated like crazy the last 10 years. If you haven't looked at C++, it's almost a new language. But one that perhaps non-mathematicians haven't spent time with is Mathematica. So the way, if you know what Wolfram Alpha is, or if you have students who are avoiding doing their homework properly, then they definitely know what Wolfram Alpha is. Then Mathematica is the programming language which is powering all the calculations in the background. So if I can launch Mathematica, I can show you a few of the things that I normally use it for. Loading. So the interface is actually very similar to Jupyter. It's a notebook style as well, where you have multiple cells that you run in any order you want, and you can edit them and reorder them. And it's I think it's the best way in terms of prototyping code for what we're doing, like scientific applications. It's not so clear what we want straight away. So to be able to experiment is, I think the interface is actually really perfect for that. So I looked up what the last thing I needed to do in Mathematica was. And it was this really simple integral, to be honest. A lot of math problems that I need to get the right answer, and I don't want to be overly macho about it and doing it by hand. I just open up Mathematica and it will give me something that's definitely the right answer. And in other cases, it'll solve lots of problems that I have no hope of solving by hand. Like I've totally forgotten differential equations, for example, most of what I learned there. So what it can do is kind of remarkable. This demonstration is going very, very slowly. So the this poor computer is not liking running a few different things at once. Okay, so half a minute. That's a lot longer than I expected. So it's taking an integral over some function, and it took a long time. I mean, because my computer's struggling, but also because it took a very general view of the problem. Like if it wants to integrate these things, it doesn't know what K and C and P are, because it could be, say, complex numbers. And if you look here, it's actually giving me a conditional result saying this integral is true if C divided by T is a complex number with a real part that's positive, and so on. It's actually figured out all the different combinations. In my case, actually, I could have made my life a lot easier because all of my constants were positive, and you can just feed that into Mathematica with the assumptions command, and that makes the computation go much faster. So if we save the result, sorry. Into a variable, we can output the result in a few different ways. So we can draw it in a more mathematical form. We can make it freeze. We can make it, draw it in spit out the LaTeX, which I'm going to talk about later, the LaTeX version of this equation. Or sometimes if I want to get a better idea of what's going on, I just start substituting in values for the unknown. So say, let's see what, I don't know what this equation looks like, but maybe if P is 2, I have a better idea. So that just substituted in the value. But if I then say, then simplify the result, now I've got a better idea of what this thing even is. Similarly, if it can do limits quite well. So you can say that thing here, kt on c squared plus ct, what does that look like if t goes to infinity? And voila. There's more demonstrations I had planned to show you for Mathematica, but I'm worried it's going to crash my whole computer, so I might just leave it at that. So I spent a long time using Mathematica, and it's really actually quite amazing at lots of things. So generating animations, for example, or plots. This is an animation I made for my thesis presentation about 2 different Monte Carlo methods. After my thesis, I fed in the document itself, the PhD thesis in, and created a word cloud just to see, like, so I could summarize to people what was in the document. And I have some slides about what that NJIT was doing inside the Python earlier, but just to make sure that I get through some of the other slides, I'm going to skip ahead and can come back to that if there's time. So the next demo I would like to show is LaTeX, and probably, I mean, every mathematician has used LaTeX. The history of it is kind of interesting. This guy, Donald Knuth, who the New York Times did an interview and labeled him as the Yoda of Silicon Valley. He was trying to write a series of programming textbooks. So that's what the photo down the bottom is, the art of computer programming. And there was no software that he could use to create the manuscript that he liked. He just thought that they were all awful. And so he went out of his way to create a whole new programming language to handle mathematically inclined document creation. And let's open one up. So this is a bare bones LaTeX document. So you start off just saying what kind of thing it is that you're producing. So I'm making an article. This could be, for example, thesis or book or different templates like that. Inside the begin and end document, you start writing the text that you want to appear. And then at the bottom somewhere, you specify where your bibliography information is. So I'm in Sublime Text here, which has just been updated recently, about 1 or 2 weeks ago to version 4. And with that, I can just hit Control B to compile this document. So it'll compile not to a computer program, but to a PDF file. Goodness, it's going very slowly today. So voila, the main reason that LaTeX is so popular is it's just really phenomenal at producing, writing mathematics. So if we just take some equations that I wrote out earlier and compile that, the syntax is, if I was to recommend people to use LaTeX, I would say definitely learn how the syntax, how to write equations with LaTeX. I mean, I think it's beneficial for lots of different purposes, but for creating large documents in particular. So I wouldn't write a thesis, or a book. I wouldn't write anything like that in Word or any other software, because LaTeX is just sort of designed for that purpose. But if you don't want to learn all the manuscript side of things, the language that it uses to express mathematics is sort of infected every other project. The LaTeX math format is sort of used everywhere, and it is quite simple, I think. And well, I tried to find some kind of complicated equations to recompute, and of course I went straight to Google for that. And this reminded me of why I dislike words equations. Like, just looking, I don't know if you can see these very well, but like, that's an equation produced in Word. That's an equation produced in Microsoft Word. So is this one. Like, and they're all ugly. Like, I have to admit, that's my bias. When I'm what's the word? Reviewing papers, I have to really hold myself back from just rejecting people's word equations because they look so bad. But here's, for example, something that's made by LaTeX. And I don't know if that's obvious to everyone, but if you've used LaTeX for a little bit, you can just look at these straight away and know what produced them. Anyway, enough bashing on Microsoft products. Go back to our equations. Some of the other cool things are when you want to reference the equations. So I can give names to these equations, something that's meaningful to me. And then later on, if I just want to talk about them, say like in equation 5, we use equation 5 to do equation something else, then this it's quite easy to do like equation referencing. And even if it's like in a different chapter entirely, it'll say, you know, equation number 2.17 or something if it's in chapter 2. That's taking a long time to compute. Similarly, citing papers and handling reference lists is just a solved problem in LaTeX, I would say. When you want to cite a paper, you just go /cite, and then so long as you have the bibliography information in the separate file, which is called the Bibtex file, then this is what it looks like. So here's a book by my supervisor, Søren Asmussen, and so on. Then each one of these has an identifier, so you can take that and say, I want to cite this paper, it'd be /cite Bakri 2013. So why did that suddenly not like that? Missing dollar. I think I inserted a blank line that confused it. Yeah, and I'm just going to mention Overleaf in a second, Sonika. I have some friends that use Overleaf quite a lot, but when things get more complicated, you want to add more and more packages that are maybe not included in Overleaf. And that's the reason I hold back. I'm often using packages that it doesn't include, but it's perfect for if you're on like the iPad or something like that, where you're never going to install LaTeX. You're never going to get that working. So this is the first part has compiled. So using inequality 1, we prove 2. These are actually links. When you can click on these and it'll take you to the equation. And it's slowly compiling the bibliography now. It seems this poor Windows laptop was a bad choice to run Zoom at the same time, and it's not liking that. And what it's doing is that it takes that raw information in the Bibtex file and produces a reference list in the style that you can choose. So you can change whatever style to fit the journal or your own personal preference. And so now the references have appeared in here. So another question, can we connect it to Zotero, other reference management software? I haven't used Zotero myself. There are programs that are that can help you manage this file. Like I'm probably an outlier for just opening the file directly and putting stuff in manually. So I don't really have experience with that. What I can tell you is that it's actually not too hard. I mean, you can easily avoid writing that information. So Google Scholar is like my first stop for this. If I need to cite a new paper, say this beautiful paper by Patrick Laub et al., then we can just hit the quotation marks underneath it. And then there's a Bibtex button right at the bottom. And this is kind of unreliable. You have to check this information, but basically you can just take that and copy paste it into your Bibtex as a starting point. Okay, so yeah, so if you want, if it seems a bit unnerving to jump into LaTeX, then yeah, this website overleaf.com is a very nice solution, and it's kind of like Google Docs as well, that you can have live collaboration on a website on a document, and while you're typing on the left, it recompiles the document on the right, so you can always see what's going on and add version tracking and comments, etc., etc. And it's free. The University of Melbourne has a subscription. Well, University of Melbourne has subscriptions for lots of things, and this is one of the useful ones. On a kind of related note, if you go to, there's a website that I use all the time, Google Engrams, and what they've done is Google has read like all the books in English and different languages, digitized them, and created a database so you can search for the relative frequency of things. So I use this for, like, this is the last time I used it. I didn't know whether effective sample size should be capitalized or not. So it's a pretty simple example, but when I'm working with co-authors and we don't know what to call something, then I just pull this up and go with the popular one. Okay, so I've got a few minutes. I just wanted to talk about, I'll be very quick with this, talk about version control and Git, for example, and the way it's used in industry. So I recently went back and, well, recently as in today, I went back and found what I was doing when I was an intern at Google. So it's quite a long time ago now, 7 years. And all this code that's committed by Pajama Llama, that's actually my account. I was very proud to have the email pajamalama@google.com, and it's this, my initials are PJL, so that's why we went with that. Anyway, this is what I'm showing you is not GitHub per se, but it's the version management software that we were using in the Chrome team. So I'll open up a specific review. So the workflow is you would write some code, a chunk of code, and well, sorry, I'm ahead of myself. Say I'm part of a team writing some software, and I want to add a new feature to it. So you start off by creating your own personal copy of the code so that you can modify and experiment without influencing other people. So that's called a branch. And in your own branch, you take small steps towards adding the feature that you want, and they are called different commits. So you have a bundle of changes to the code. You describe what you've done in that bundle and commit it. And then after you've done a few commits, you solve the problem that you want to do. You try to re-merge it back in with everyone else so that your beautiful new feature can be shared with the rest of the team. And at that point, at Google, they would have code review. So before any code was allowed to be used, it would go through almost like peer review process where you would send in what you want to change. So what's something interesting to look at? So inside this commit, I changed a bunch of files, and this is like the before and after for what I changed for that on that particular day. And then I would be looking for this LGTM. Looks good to me from one of the other engineers. And once that was achieved, then it would be merged in. And I was a bit shocked by this. It was like kind of an eye-opening experience to me, but every single line of code at Google or Facebook or Amazon, for that matter, is read by multiple engineers. So, so this is some other change. And so, for example, there's one file that I changed that's 34 comments on it from the reviewer who was my advisor. And it would be really nitpicking. I mean, they would even write here, this is a nit, this should have had been on a new line here, for example, that it was complaining about. And other times I had the wrong variable name. I was using the word file when it was sort of more appropriate to use the word path, or like path of a file name. And so it was really with I had to satisfy him, and to the point that he would allow me to bring the code into the main repository. And I'm kind of mentioning this because it's kind of the total opposite. There's no equivalent in academia, I think, for most people writing documents. Like if I look at my email list, there's lots of like Word document v3.2.1 updated / fix this, final copy kind of thing. It's not, there's no real there's not the same level of rigor. And so I sort of bent my friend's arm when we were writing a paper together recently to actually use Git, and he sort of became converted to it. So now I can look back at the paper and say, see, okay, on 27th of April, he changed section 5.4 of the paper and fixed this or changed whatever notation. Anyway, I don't have enough time to go on about the glories of Git, but admittedly, it can get quite complicated. So I've included some YouTube video links here that explain some of the more rebasing or changing the history of a commit. Okay, so down to the last few minutes. So onto my last demo, which is how can we easily make a website to showcase our code, showcase our research. So this is an example I found that I'm just super impressed by. These guys wrote a sequence of papers about inverting Laplace transforms, and they managed to get the website InverseLaplaceorg, already an impressive feat. And so in here, they've got some description of their method, the different papers and how you would cite them in the series, explaining the relevance to each other, how you download the code. But the coolest part is actually have the code, they implemented it in JavaScript in the browser so that anyone can actually run their algorithm and see the performance against the other common methods for inverse Laplace transforms. And you can change the input. You can even put in your own function here to to play with. So this is sort of an ideal situation for sharing research, or even just for the sake of teaching. This website is something I pull up like every time I'm trying to explain this statistical concept, Markov chain Monte Carlo. I bring up this animation because the algorithm is quite convoluted, but once you see it in action, it's really beautiful too. So I owe this Chi Feng, I owe him or her quite a lot, because I've shown this animation off to lots of people. Anyway, so let's quickly go about the last demo if possible. So I found, I just searched for a simple template to create a GitHub Pages website, and I found one to make a resume. So this is kind of what it would look like at the end of the day. Let me close some tabs so I'm not using too many resources up here. So this is the GitHub page. It's just the website where this person has stored that code that will create the website. And if you can, one step away is to hit download zip. So I've done that already. I'm going to create my own new repository to host the website. So new, we'll call it resume, make it public. We can make private repositories for free on GitHub, I think, for education, if you apply for the education discount. So I'll just reconnect to that Melbourne Research Cloud machine. Go down to a folder where I want to download. So I've created a blank repository where I want the code to be, and to get a copy of it so I can start playing with it, I copy the address here. The syntax is git clone, and then you dump the URL there. You appear to have cloned an empty repository. Okay, perfect. And so we can just take the code that the template code, copy the whole bunch into our resume local repository, and start playing with it. So once that copies and uploads to Dropbox, I should be able to run this command, bundle exec Jekyll serve. I was just waiting for those files to be converted over on Dropbox. And what that command will do is it will create the website. Sorry, I didn't go into the folder. It'll create the website the template gave us, localhost 4000. So here we are. This is just the blank version that we can play with. And inside, really it's only one file that we need to modify, this config.yaml. And it's been set up by the author to be quite easy to change. So he's already got spaces for all the different information that we'll want to update. So we can do that really easily. Put my name in, that's not hard to do. There's a section for all the social media links. I probably wouldn't have that many if it was a resume. I can put in my org ID. There's an about me section. This section, we don't need anything in there. In the about me, there's a reference to where the photo is. There's space for, so I've just found a photo of myself, patch.jpg, and bring that over. To there. And then it has lots of space for projects and your education and so on, but really I'm just going to put in the last section, a list of papers. And to be honest, it did take me a long time to write this list, and because I'm including links to each of my co-authors. So I work a lot with Pierre Goffard, and when his name appears, there'll be a URL to his website. And the reason for that is it's to try to improve my search ranking in Google, to be honest, because it will look at this kind of information, what links are to my site and what links I have from my site. So rerunning that Jekyll command and reloading the website, we have a usable website slash resume, online resume. And as I mentioned, these are all links to the different people or to the code or the archive of my papers. And as the time is up, I'll only just very briefly show you how it would actually get this on public. What you would do is you just need to re-upload it to Git. So once you use Git a few times, it's these commands are sort of memorized. You say, I want to add all the files, I want to commit them, give it a name, some sort of description, first version, and then git push. And then once that gets up to this website, so this is the empty repository. If I hit refresh, it's already included all that code we just did. We need to, and then to make it into, to tell GitHub that it's actually a website that it should be creating, you just go into the settings and just flick a button here. So say, tell it my master branch is a GitHub page. And then it says your site will be published at here, pat-laub.github.io/resume. The first, this, I'll be honest, this won't work straight away because when you upload a site, GitHub usually takes 10 minutes or so to actually show it publicly. But I uploaded a different version, I mean the same code to a different repository earlier, and so this is the public version of that website. Okay, I think yeah, so I'll just finish up. Mainly I just wanted to show you today lots of things that exist. Like maybe you don't know that some of these things are possible, or at least they're not so easy to do. Some of them are actually quite easy. And I would say, be brave. Try out something new, some new technology on your next project. And you maybe don't try a lot of new things at once. I've had that mistake. I made that mistake in the past, but try at least one new thing on each new project or each new presentation that you're giving. And I'll stop there. Thanks very much.
Thanks, Pat. It's kind of a run through a bunch of interesting resources. Does anybody have any questions or comments? Feel free to chime in. We've had a couple people include things in the chat.
Thank you.
Did you address this one, the Mandalay? Can we connect it to Zotero? I know that you covered the Overleaf.
Well, that's the one where I believe they're like versions of what I showed, which was Bibtex, versions of that for Office products for Word. So I don't I don't have lots of experience, so that's all I know about it. And I think there are some software that makes the process a bit more user-friendly for LaTeX, but I don't have experience, so I really can't address that one, sorry.
Fair enough.
Markdown or LaTeX. I think they're both great. A great option. So I mean, I can show you like the notes. Am I still sharing the screen? I make that mistake all the time of stopping sharing or sharing the wrong screen. Whenever I'm writing something for my own personal use, I'm using Markdown because it's just so easy to drop in and out of code or in and out of math. But for producing a whole research paper, I'd be preferring LaTeX.
You can too. I mean, you noted, and it's true. You can really spot aesthetically, even just via Google Images.
Yeah.
What's been produced and saved from LaTeX. I know that some people, like for example, in psychology, it's quite common to use kind of aftermarket software like MathType or something that interfaces with Microsoft Word. You have to pay for that. And you know what it produces is fine, but Word is so buggy, of course, that it's crashing often. And then also the autosave, like whatever the auto backup, autosave feature is in Word, it'll often convert the equations to images, and then you're screwed. So MathType had to produce some image reader basically to reconvert them back into MathType, which doesn't always work. And so sometimes you'll end up, you know, when you're done with the Word document, a bunch of the MathType equations have been saved to images, and then you have to try and convert them back into MathType, and sometimes that doesn't work properly. And it's just a nightmarish scenario for so many reasons that I just quit entirely. And so I don't know if anybody else has had any experience like that, but obviously what you're showing would have none of that.
Wow,
and then
I think that's the great thing about open source. When you get people who are very opinionated on, say, typography,
right,
there's nothing they can do to make Word better. Like, but they can make packages and improvements to LaTeX. And at one point, Donald Knuth was sending out checks to people who found bugs in LaTeX. And,
oh, really?
Yeah, for like a less than $1 or something, and people would keep it as a keepsake, and
yeah, of course.
So.
That's funny. Oh, that's somebody who, yeah. That's Bill Gates is not doing that. Let's just leave it. Let's just leave it at that.
Thanks to everyone in the chat. That was a lot of good questions.
Yeah. Does anybody want to chime in? Don't be shy. This is the last QMNET talk for the semester. We'll take a break and we'll come back, hopefully refreshed and, my goodness, set in the context of a lockdown. But thank you so much for this, Pat. We really appreciate it, and we'll pop this up on the YouTube channel ASAP.
Thank you.